interfaces and abstract classes. What we're going to start to focus in on now are two special ways Java helps us to implement polymorphism to the nth degree again. And what we're going to do is start talking about special classes called interfaces and then special classes called abstract classes. And we'll start off talking about interfaces first. And what we're going to see is that an interface helps us achieve polymorphism, and it helps us combat the fact that a class can only inherit from another class. So what I'm going to do is kind of define for you what an interface is, as well as how you're going to use it. Now, let me just say this about interfaces, and I'm going to repeat it multiple times because it's worthy of being repeated. I already talked to you a little bit about GUI applications, and you hear the word interface in GUI, right? Graphical User Interface. And this has nothing to do with graphical user interfaces at all. Interfaces are a special type of Java construct. Now we can use them in graphical programming, but we don't have to. So I need you to divorce yourself from thinking when you hear the Java term interfaces from graphical user interfaces. And another way we can implement polymorphism and have inheritance is by using abstract classes. So again, I'll define for you what an abstract class is, as well as why you would want to use an abstract class. The challenging thing about interfaces, I think, mostly, is understanding them, because you have to really get clear that interfaces have nothing to do with graphical programming, okay? We are dealing with no GUI whatsoever. Again, you'll see that we'll use them in GUI programming, but I could create my own interfaces for whatever I want. Now, they help you achieve polymorphism. And what they do is help you accomplish that by alleviating the limit that Java has on us of single inheritance. And it is said that Java inheritance, or inheritance in general, really defines that is a relationship, like, oh, a person is or rather an employee is a person, or a fireman is or an, civil servant. That's inheritance is a. Well, it is also said that an interface just gives us the is part. In other words, a fireman is fireable. Fireman could get fired. An employee is fireable. And here's the cool thing about interfaces. As I said earlier, Java only gives a single inheritance. Now, I say that as if it's a bad thing. The single inheritance feature in Java is absolutely a great thing. The only language that supports multiple inheritance is C++, and it becomes extremely confusing and hard to manage. As a matter of fact, all object-oriented programming languages since C++ have really cut that out and only allow you to do multiple inheritance. Examples would be Java, C#, and VB.NET. Now, all languages have interfaces that help you overcome the limitation that C+ or that single inheritance puts on there, namely the single class that you can inherit from. Because a class can implement multiple interfaces. I can implement as many as I want. And we'll take a look at what they're all about. Now, the easy part about interfaces is actually writing them, because they don't contain any code. You see, interfaces are really defining. They're used to define definitions of classes on how they're supposed to behave. Then you implement that, and then you have to implement the code there. Okay? So they don't contain any implementation code whatsoever. No implementation code whatsoever. Now, because of that, because you kind of inherit them in a certain way, that means all the methods in them are implicitly public, and the constants are implicitly static and final. Okay, so it makes using and working with interfaces a lot easier. The other thing is when we're implementing them, and implementing them simply means we're going to use the implements keyword in the class that's implementing the interface. So let's go ahead and practice this. I've got a couple of classes that I've already set up here because I've got a kind of an elaborate example I want to go through. Now, this is two classes. I created a Java compilation unit, a .java file called workers.java. And I created two classes. I created class person and class employee. And class employee extends class person, okay, which means it inherits from person. So let's take a look at what's happening in the person class. Here, I'm defining 3 class level fields, and they're private, which means I've locked them down, and they're only accessible within the class. And I created 2 constructors. I created my own default empty no argument constructor, which simply initializes everything to the first name and the last name to empty strings and the age to 0. Otherwise, you can use an overloaded person constructor, which takes an ln, which assigns to the string last name, a first name, which makes your first name, and an a, which goes into int age. Then what I've done here is I've created 2 public methods, and one method is called getName, and it returns the concatenation of the first name and the last name. The second method is called getAge, and it returns age. Now, this is called encapsulation, and encapsulation is one of the 5 tenets of object-oriented programming. Here's the idea behind encapsulation. You lock down all of your with private all of your class level fields, okay? And then what you do is provide special methods called get methods, that's why they'll always start with get, to return the information, or set methods to actually alter it. And if you encapsulate configuring of your variables inside of these methods, you actually have more control over it. Okay, so that's what's going on with the person class. The employee class extends person, and it's got 2 private level fields, string called str job title and float salary. Now, I've created 2 constructors. The first constructor, again, is the default constructor, and it initializes the job title to the receptionist with a salary of $25,000. So if you just create an employee, it's automatically going to be a receptionist making $25,000. Then what I did was I overloaded the employee constructor with my own, and it takes a last name, a first name, an age, a job title, and a float. Look at this, super. When you deal with inheritance, there might come a time that you want to call a constructor of your parent. And that's exactly what I'm doing. This calls the parent's constructor, the 3 argument one. So what happens first is it instantiates an instance of the person class by passing in the appropriate parameters. Then what it does when you create an employee using this constructor, after it instantiates a person with the following information, then it sets the job title and the salary. I've provided 3 methods, one called getTitle to return the title, 2 called getSalary to return the salary, and 3 called getName. And I've got some logic in the getName one. If you're a doctor, I'm going to append doctor, and then I'm going to call the super getName. Again, super always calls up to the parent. So super here would refer to getName here, and it would just append doctor to it and call that. If your equals true, if string job title dot equals, which is a method of the string class, and it is equal to the text or the string doctor, then what I'll do is I'll append doctor to it and call the parent getName. Otherwise, I'll just call the getName method from the parent. Now what I'm going to do is create an interface. So let me create a new file, and I'm going to create it from scratch. And it's going to pretty much look like a regular class, but there's definitely some noticeable differences. I'm going to say public, and instead of saying class, okay, I'm going to say interface. Interface. There we go. I was spelling that right. And I'll call this fireable because, well, unfortunately, sometimes employees are fireable, or at least they get fired and they have to be fireable. Okay, so create that. And in there, I'm going to create a method, and it returns a float, and I'm going to call it fire. And let's say this will just go ahead and pay them their last check. Pay them their last paycheck. Now, notice that I have not implemented the code within the interface. I haven't done it. All I do is I define what the method is. That's all I do. I define what the method is. So I'm going to save it, and I will call it fireable.java. Okay, and I'm going to compile it. So let me do control 1. Now, what I want to do is I want to show you what's created in my directory. So Java interfaces abstract. Let me bring up that folder. Okay, so here you can see in the directory that I've got my employee class, my Fireable class, my person class. Here is the fireable.java that is compiled into that class. So notice how it becomes a .class file. And here's my workers.java file. And that workers.java file, what that does is become the employee and the person class. Okay, so now what I want to do is go ahead and utilize my interface. So let's go back to the class that I'm working with. So here's my workers.java, and I'm going to come down to my employee class right here. Now it's already inheriting or extending from the person class. Now what I'm going to use is the implements keyword. Implements. And I'm going to say fireable, the name of the interface. Now, I can implement as many interfaces as I want. And I just say comma and, the next interface, comma, well, I shouldn't say int because that's, but the next interface, the next interface, the next interface. Okay, I can just go right ahead and implement as many as I want. Now, here is the key rule about using interfaces. What's cool about using interfaces is that you have to implement the interfaces method within the class that's implementing the interface. Okay, I know that's a mouthful, but that's how it works. See, what's good about interfaces is I could come over here and I can define several methods and constants that are unique to all classes that interface it. And therefore what I can do is I can create a nice library and a nice standard of coding that says, look, I want you to always implement these methods within your classes. And the cool thing is that let's say I've got a fireable interface called fireable here, and it has the method fire. Well, if the employee is or if the class that's implementing rather is an employee class, I can implement fire down here and fire an employee one way. And if it's, let's say, somebody like an elected official, and I can say fire, well, I can implement that another way, i.e. we just, don't re-elect that one individual. Okay, so people can get fired in all different kinds of ways, but yet they still get fired. So now you see the polymorphism. So I'm going to compile this now. I'm going to do control 1, and I'm going to expect to get a major bomb here, a big error. And as you can see, I got the error, and here's the error. Cannot resolve symbol fireable. Okay, because I spelt that wrong. So yes, I did get an error, but that is not the error that I want. So let me kind of spell fireable correctly. F-I-R-E-A-B-L-E. All right, let's go ahead and control 1 again. Now this is the error that I wanted to see. Employee is not abstract and does not override abstract method in fire. In fireable. The fire method does not override abstract method fire in fireable. Okay? And it's saying basically what's going on here. So I have two choices. One is I can make employee abstract, and I'm going to talk to you about that here shortly. Or two, I can go ahead and implement the method correctly. So let's go ahead and do that. So I'm going to come down here and I'm going to create a method. So let me just kind of scroll down to the bottom after my return my getters, what I like to call the getters or the accessor methods. And then I'm going to come down and say public float, and it's called fire, not file. And now I'll go ahead and implement the method. And basically any code that goes out in there, will be whatever. So I'll do a system.out.println, and I'll steal somebody's famous quote these days is, "You're fired." Okay. Now what I can do is I still have to return something, so I'll return, your current salary divided by, let's say there's so many days or whatever, so divided by, 15 or something like that, whatever. Okay, now I'm going to do a control 1 and compile that. Oh, let's call it float salary. So it's FLT salary. All right, let me recompile. And here we go. So that is how you go ahead and use interfaces and what they're all about. Now, the next thing I mentioned, or I already mentioned something called abstract. You saw that error that I got. So let's start shifting gears and talking about abstract classes next. I like to teach abstract classes by asking people a couple of kind of poignant questions, and all of a sudden the nature of our discussion here is going to become rather philosophical, but fun, so bear with me. Here's a couple of questions. The first question, simply put, have you ever seen a shape? Now, some people might be quick to say, oh yeah, I've seen a shape. And then my response would be, well, what does it look like? I mean, after all, these are various shapes. This is a cube. This is a cone. And this is a sphere. But yet they're all shapes. And I think you understand that I can literally draw an infinite amount of shapes. How about this? Have you ever seen a stick figure? Oh, sure I have. Oh yeah, what does it look like? Well, this one doesn't have a face. This one has a smiley face. This one has spiked hair. This one is wearing a hat, and this is a small one. So here's the deal. You have seen instances of shapes. You have seen instances of stick figures, but you've seen unique instances of them. You haven't seen a stick figure. You've seen a unique instance of it. So what's the deal about a stick figure? What's the deal about a shape? Well, you see, all shapes, and consequently all stick figures, have something in common. Let's focus on something that's a little bit more realistic here in the shapes. Now, true, all shapes have a different look to them. They have different dimensions, but yet all shapes allow you to do things like calculate their volume, calculate their area, calculate their dimension, okay? Calculate a perimeter. Uh, these are 3D dimensions, so they're cubic, how many cubic centimeters they take up, okay, volume. But yet they do it differently. So what I can do then in Java using abstract classes is define a class that has general commonalities that all classes will use. And the word abstract locks that class down and prevents it from being directly instantiated. The purpose of an abstract class is to go ahead and put all your common stuff in there, lock it down, because it's really goofy to instantiate an instance of the shape class. What is it going to really give you? It's goofy to maybe instantiate an instance of a component class. What is that really going to give you? No, what you want to do is provide a lot of functionality in these classes, but lock them down so other classes can only can inherit them. And thus I can create a Robert shape by extending the shape class. So let's go ahead and put this into practice. A perfect candidate to become an abstract class, I think in our example here, is the person class. Again, what do I really get by instantiating an instance of a person? I really don't get a lot. Okay, so I'm going to go ahead and make that an abstract class. And I just put abstract right in front of it. And now it's an abstract class. Now, there's another thing I can do. I can go ahead and create abstract methods. And an abstract method just contains the method definition. So I'll come down here and I'll go ahead and create an abstract method because all people take vacation. So public abstract, and it doesn't really return anything, and I'll say take vacation or take PTO, right? Because nobody really has vacation time. It's all paid time off these days. Now here's the deal. If I go ahead and create an abstract method in a class, then the class itself has to be abstract. But yet not all methods in an abstract class have to be abstract. Take time to think about that, but check it out. This is an abstract method. Notice how you don't even put the curly braces in it. You just define it. These two methods are not abstract. They have implementation code. They both return a value. This does nothing. Now, if again, I go ahead and create this, let me go ahead and compile it, and you're going to see a slight difference. Notice that, or recall rather, that my employee class extends the person class. But I haven't implemented the abstract take PTO method. So let's see, do I get an error or does it compile? And I get an error because employee is not abstract and does not override abstract method take PTO in the person, so public class employee. So in other words, I need to go ahead and deal with this. So let's come back. It is going to be public void take, with my mouse, PTO. Okay, public void take PTO, and system.out.println. I am taking precious time off to paint the house. And I won't go into the details as to, the fact that I'm usually being coerced into doing something like that. Okay, so now I'm implementing that. And here's the deal. Any subclass or child class that implements an abstract method declared in the parent or the superclass, you need to go ahead and deal with that. If in fact the subclass does not go ahead and provide any of the implementation, I'm going to get this compilation error. It's not going to compile. Now, I don't have to go ahead and code this thing up. I could just stub it out. In other words, I could just leave this blank and just let it sit there. Okay? Note, any class without any implementation of an interface must also be an abstract class. So now if I compile it by doing an control 1, it will go ahead and compile. And here you can see it compiles. Now, this stuff is utilized a lot in Java. And if we just go out to the Java website here, you will see that it is implemented in various places. We've already kind of seen some examples. What I'm doing is I'm going to give us some example from the swing classes. Remember, the swing classes allowed us to go ahead and create GUI applications in Java, those Windows forms and frame applications with buttons and labels and things like that on there. I want to go ahead and click on the JButton class. The JButton class has a really nice family history. I mean, just look at this. Here we have the JButton class. And look at this. It inherits from the abstract button class. And I think by the name of it, you could probably already tell that that class is abstract. Let's go ahead and take a look at the class definition here. Here we see public class JButton extends abstract button and implements accessible. You know what that means now. You know that this is a public class called JButton. It's not abstract, so you can directly instantiate it. It inherits from abstract button, and it uses the accessible interface. Let's go ahead and click abstract button, and let's see what's going on with that one. Look at this. Public abstract class, abstract button. It's public, it's a class, it's abstract. You cannot directly instantiate the class. You can only inherit from it. It itself inherits from JComponent. So abstract button is a JComponent. And look at this, it implements two interfaces. So this is a very common practice throughout the Java API. Now, will you necessarily be writing your own abstract classes and interfaces right out the gate? I highly doubt it. But will you be using the Java abstract classes and interfaces that come with the Java API? Oh, I highly think so. In interfaces and abstract classes, I taught you how to use interfaces and what they're all about. I showed you that an interface is essentially a special kind of a class, but you don't use the word class to go ahead and create it. Use interface. And what you do is you provide methods without any body in there, and they're implicitly public. And you go ahead and you create a class that implements your interface. And a class can implement as many interfaces as you want, and you can achieve polymorphism that way. You can also use abstract classes, which cannot directly themselves be inherited. Instantiated, you must inherit them. And what you can do in abstract classes, rather, is you could go ahead and put in things like non-abstract methods as well as abstract methods, and then you can achieve polymorphism that way. You're going to see this utilized all throughout the Java API. And I'm going to point this out as we continue along. I hope you have found this informative, and I'd like to thank you for viewing.